Algebra and physics this year, so we need to make sure we're all on the same page. The thing we need to know is that we're going to be using letters to represent different variables. Variables represent numbers, so like speed is a variable, but or velocity is a variable. So if I write the letter V, I'm representing a specific velocity. So like I could say my velocity is 30 meters per second. So that V is actually standing for something. I can use that as a placeholder in an algebraic equation when I'm solving for it. Whenever we're doing algebra, it's important to do everything in the correct order. We're going to use PEMDAS, or Please Excuse My Dear Aunt Sally, and to remember what goes when.
I've been first and I've been last. Either way, I keep the order with PEMDAS. First is parentheses, then it's exponents. Multiply, divide, add, subtract. Yeah, you know this. Evaluate expressions. I have some patience. I just follow the order of operations. I simplify to see what they equal. Pem comes first and DAS is the sequel. PEMDAS, yeah, that's an acronym. We'll break it down just to see what is happening. P is parentheses, search for them first. Whatever is inside them, you need to do the work. E is exponents, so raise them up. Or get down with the roots like Questlove does. MD, multiplication and division. I do them left to right, yes, that's my decision. AS, addition and subtraction. You learn them first, do it last, that is the fashion. Some say please excuse my dear Aunt Sally, some say PEMDAS. Either way the order is important, just like swim class. I've been first and I've been last. Either way I keep the order with PEMDAS. Okay, let's say that we've got this. Let's use PEMDAS, see what we accomplish. First we do what we see in the parentheses. 17 minus 15, that is 2 indeed. 3 plus 1, that is 4, yes I'm brilliant. Now, exponents is what we'll be dealing with. 4 to the second means 4 times 4, that equals 16. And yes, I am sure. Next we multiply and we divide. 16 times 2 is 32, oh my. 32 divided by 4 is 8. And then we add or subtract, okay? 8 minus 5 is 3, which is easier than writing this to me. Cut through your operations just like a surgeon. Flowcat, yeah, we keep it working.
Number 1 says, using strategy 1, we're going to use the formula F equals ma. That's force equals mass times acceleration. Okay? How much force is required to accelerate a 12 kilogram mass at 5 meters per second squared? So I'm going to start off with my givens. I know that 12 kilograms mass is going to be my m, my mass. And that 5 meters per second squared is going to be my a, the acceleration. So now I just plug those into the formulas to substitute for the m and the a, and I'm left with 12 times 5 is equal to 60. But our answer is going to be in newtons, because we answer our force in newtons. Make sure you include your correct units whenever you're doing this.
Not big newtons.
Right. Okay.
You use a triangle. And within the triangle, you have 3 parts. You put the F in the top, and then the M in the bottom, and the A in the bottom, so that force is going to equal mass times A. Notice that the variables MA are side by side, and so when they're side by side, you multiply. When there's one on top of each other, that means you divide. Okay, so I'm going to draw another triangle, and I'm going to put my numbers that correspond to the variables in it. Okay, my mass was 12, so I'm going to put a 12 in the lower box, and my acceleration was 5, so I'm going to put a 5 in the box where the A was. Now, if you notice that I'm missing a box, that's my variable that I'm trying to find, so I'm going to put an F there. Okay, notice how I just moved it right over. Alright, so now if you look, do you see how 12 is beside 5? So that tells me I need to multiply. So 12 times 5 is 60.
Still gives you the same answer, either way you do it. But remember to include the N for newtons. Always include your units. Okay, so we're going to look at problem number 2. We're going to give you a couple of different strategies to do this one also. We're going to use the same formula. Force equals mass times acceleration. What is the mass of a falling rock if it produces a force of 147 newtons? Okay, so I'm going to start plugging in numbers I know. This problem looks like it only gives you one given, and that's the newtons, 147. But it also tells you it's falling. We know that gravity has an acceleration of 9.8, so that's going to be our other given. So we're left with 147 is equal to mass times 9.8. Now we've got to get mass by itself because that's what we're solving for. We've got to isolate it. So we're going to divide both sides by 9.8.
And I divide because right now they're side by side and they're multiplying, so I want to do the opposite. So the opposite of multiplying is dividing. So I'm going to divide by 9.8, and what you do on one side, you've got to do on the other.
Think of it like siblings. When my brother got 20 bucks from my mom, I wanted 20 bucks from my mom also. So whenever you do that math, you get a mass is equal to 15. But we're going to say that's kilograms because that's how we're going to measure mass.
I put it on the wrong side, sorry.
That's okay. All right. So now you've got another strategy. You're going to show us the triangle again?
Yes. I'm going to try to do the triangle. All right, I'm going to set up my 3 sections again, and I know that force equals MA. Okay, so I'm going to draw my triangle again. And from my variables from the problem, my force was 147, so I'm going to put 147 in the top box. And then I don't know my mass, but I know the acceleration due to gravity was 9.8. Okay? Now using the triangle, can you see exactly what operation needs to be done? You can see that the 147 is on top of 9.8, so when they're on top of each other, you divide. So mass